Our universe is a vast, dark ocean, and we live on a tiny island of rock and water, looking up at the countless points of light. We dream and build ships to sail that cosmic sea. One of the greatest of these ships was a probe named Cassini, destined for Saturn, the jewel of our solar system. Launched in 1997, Cassini was more than just a machine. It was an extension of our senses. It was our eyes, ears, and hands, sent on a 20-year journey to explore a world 6 times farther from the sun than we are. The journey itself was a marvel of celestial mechanics. Cassini didn't fly straight to Saturn. It performed a cosmic ballet, swinging by Venus twice, flying past Earth, and using Jupiter's gravity for a final boost. Each flyby was a gravitational slingshot, adding to its speed. After 7 long years, Cassini arrived at Saturn in 2004, becoming the first spacecraft to orbit the ringed planet. It carried a passenger, a lander named Huygens, destined for Saturn's largest moon, Titan. The mission was a collaboration between NASA, the European Space Agency, and the Italian Space Agency. The mission's goals were ambitious: to understand Saturn's rings, study its moons, and analyze its stormy atmosphere. Cassini was equipped with 12 powerful scientific instruments, ready to rewrite our textbooks on the outer solar system. Saturn's rings, its most famous feature, are a chaotic, dynamic system of countless particles. Cassini showed us they are not solid, but made of water ice, sparkling like diamonds. Cassini flew through the gap between the rings, revealing intricate structures, waves, and ripples. The rings are a living, breathing system, not a static relic. Cassini discovered propeller-like structures and vertical formations, suggesting constant reshaping by gravitational forces. The rings are a dynamic laboratory for understanding planetary systems. Cassini detected a constant shower of particles falling from the rings into Saturn's atmosphere, indicating the rings are eroding. This discovery suggests the rings are younger than Saturn, possibly formed from a shattered moon or captured comet. Dr. Linda Spilker noted, "The rings are not a permanent feature of Saturn." The idea that these structures are temporary is humbling, reminding us the universe is in constant change. The images from Cassini were evidence of a dynamic, evolving system, a cosmic crime scene where a moon may have been torn apart. Among Saturn's moons, Enceladus delivered the biggest shock. Cassini saw giant plumes of water vapor and ice particles erupting from the moon's south pole. A moon this small and far from the sun should have been frozen solid, yet it was active. Cassini performed daring flybys, flying through the plumes and analyzing them. The plumes contained water, salts, silica, and complex organic molecules, the building blocks of life. The presence of silica suggested hydrothermal vents on the ocean floor beneath the ice. Enceladus must have a global liquid water ocean hidden beneath its icy shell. Tidal heating from Saturn's gravity generates warmth to keep the water from freezing. Enceladus became a promising place to search for extraterrestrial life. This discovery changed the paradigm of where we look for life, showing it could exist far from a star's warmth. Dr. Chris McKay said, "Enceladus has rewritten the textbook on habitable worlds." Saturn's largest moon, Titan, was a primary target for Cassini. With a thick, hazy atmosphere, Titan's surface was hidden from view. The Huygens probe, piggybacking on Cassini, was designed to find out. In 2005, it landed in what looked like a dry riverbed. The rocks were water ice, frozen as hard as granite. The rivers were filled with liquid methane and ethane. On Titan, methane plays the role water does on Earth, with a complete hydrological cycle. Cassini's radar mapped Titan's surface, revealing vast seas and lakes. These are the only stable bodies of surface liquid in the solar system besides Earth's oceans. Titan is a natural laboratory for studying prebiotic chemistry. Its atmosphere is rich in complex organic molecules, precursors to life on early Earth. By studying Titan, we glimpse what our planet might have looked like before life began. Saturn is a gas giant with a turbulent atmosphere. In 2010, Cassini witnessed a monstrous storm, a planet-encircling tempest. It started as a small white spot, growing to wrap around the planet. The storm, named the Great White Spot, provided incredible scientific data. Cassini analyzed its temperature, wind speeds, and chemical composition. The storm's lightning was 10,000 times stronger than Earth's. It was a display of atmospheric power, dwarfing anything we've seen. The storm served as a reminder of the forces at play on other worlds. It provided a real-world example to test our models of weather and climate. The storm raged for over 200 days, leaving a swirling vortex. The Great White Spot was a scientifically invaluable event, showing even serene gas giants are places of unimaginable turmoil. The relationship between Saturn's rings and its moons is an intricate dance of gravity. Cassini revealed this dance in stunning detail, discovering tiny moons orbiting within or near the rings. These shepherd moons influence the ring particles, sculpting the rings into sharp edges. Without these moons, the rings would dissipate over time. Cassini's cameras captured moons like Prometheus and Pandora weaving in and out of the F-ring. These observations provided a living example of how planetary systems are built. A tiny moonlet, nicknamed Peggy, was a window into the processes of accretion. These small moons are in a constant gravitational tug-of-war with the rings and Saturn. The system is not stable forever, a snapshot of a moment in cosmic time. The forces that create the beauty of the rings are also a source of constant change. It's a reminder that the universe is a dynamic and sometimes violent stage. After 13 years, Cassini was running out of fuel. Mission planners decided to dispose of it safely, planning the grand finale. This was a series of 22 daring orbits through the gap between Saturn and its rings. These final orbits provided unprecedented data, measuring Saturn's atmosphere and mapping its gravity and magnetic fields. On September 15, 2017, Cassini made its final plunge into Saturn's atmosphere. Traveling at over 70,000 miles per hour, it became a meteor, burning up. As it descended, its instruments collected and transmitted data until the signal was lost. The end of the mission was a somber moment for those who dedicated their careers to it. Dr. Earl Mays said, "The spacecraft is gone, but the science and data will flow for decades." The grand finale was a final, selfless act of scientific sacrifice, protecting potential life on Saturn's moons. The Cassini mission changed our perspective, transforming Saturn into a complex, dynamic system of worlds. It expanded our understanding of where the ingredients for life might be found. The discovery of a subsurface ocean on Enceladus opened a new frontier in our search for life. Cassini's images showed the scale and power of the universe, humbling us with how much we still don't know. The temporary nature of the rings and the alien chemistry of Titan remind us of our fragile existence. These discoveries challenge us to think bigger and appreciate our place in the cosmos. The legacy of Cassini is a call to action, giving us a roadmap for future exploration. Missions to explore Enceladus and Titan are no longer science fiction. Cassini embodied the spirit of exploration, answering old questions and posing new ones. By sending robotic emissaries, we extend our presence into the cosmos, learning more about planets and life. This knowledge enriches our culture and inspires future scientists, giving us a better understanding of our world.